Hi, my students. Let's try lesson 61. This is kind of a good lesson because there's really no calculations involved at all. It's kind of theoretical and maybe a little bit annoying, but I'm going to try and break it down for you so that it is simple and not as wordy as the book presents it. The basic concept is that we're going to talk about the theoretical categories of numbers that mathematicians have devised over the years, and we're going to be drawing a picture together. If you look on the bottom, it's on the bottom of my page 249. It's a chart that has squares inside of squares, and the title at the top of it says real numbers. We're going to be drawing that together and talking about it as we go. So that, just so you know, that's roughly the picture that we're drawing. So I'm going to draw it on my page, big, like so. And I hope my camera is serving you well. Okay, so I've taken up most of my piece of paper with a great big square. I guess I drew it a little farther than you can see, but that's okay. And then I'm going to divide it. And you can see I'm just drawing the boxes the way that they are in the book. And I'm going to draw all the boxes first so that I'm not getting confused. But we're going to start, instead of at the outside of the boxes, we're going to start in the middle, in the inside of the boxes. And I want you to go back in time. I'll let you finish drawing. I want you to go back in time to when you were a tiny little person and you probably sat on your mother's lap and she probably counted your fingers and your toes for you. And when she did, she used what we call the natural or counting numbers. And she would go to your toes and she'd go 1, 2, 3, 4, 5. And it would be so exciting. And you probably copied her and did it too. You did not say, I have 0.367 toes. You did not say, I have 1 4/4 toes. You said 1, 2, 3, 4, 5. Natural counting numbers. So that's where we start in our theoretical categories of numbers. The next thing that you did when you got a little older and you reached your hand in the cookie jar one day and you found there were no cookies left, you learned the concept of whole numbers because they include the counting numbers and 0. You learned the concept of 0, and that is how you bumped up from natural to counting. So that's what is new and special about the difference between whole numbers and natural numbers is just the concept of 0. So that is how your sense of numbers developed. Later in life, you might have started receiving an allowance, and at some point you probably wanted to buy something and you didn't have enough money and you wanted your mom to give you an advance on your allowance. And that's when you started playing with the concept of integers. Because integers include the ideas of negative numbers. And you gained an understanding when you tried to borrow against your future allowance, you gained an understanding of going into debt or negative numbers. Instead of your mom giving you an allowance each week, you wanted an advance on your allowance, and that is how you started to understand what integers are about. Notice that integers do not have any fractions or any decimals. They're just those natural counting numbers, including 0, with the negative partners that they have. But there's no funny fractions in there. Fractions come in when we talk about rational numbers. Notice the word rational includes the word ratio. Anytime that you're talking about a ratio, you're talking about a number with a numerator and a denominator. I'm substituting my abbreviations for those because I don't want to get too long, or I don't want to write too much. But any rational number can be expressed as a fraction with a numerator and a denominator. So, of course, we know that a number like 3 can be expressed as a fraction because we can make it 3 over 1. But we've got all kinds of things like 2/3 and 47 over 209. We can do all kinds of crazy things with ratios. And we can make them negative let's make this negative 97/40. We can do all kinds of crazy things. But as long as our numbers have a top and a bottom, then they are considered rational numbers. Of course, all of these guys can be expressed as rational. That's why we've drawn the picture with all of these boxes that are getting smaller as we go. But there are some numbers that cannot be expressed as fractions, and we refer to them as irrational numbers. And I like that expression because sometimes they make us feel irrational when we're using them. There are a couple really great examples of irrational numbers. A lot of our square roots are irrational numbers unless they come out evenly, like something like square root of 9. Well, that's equal to 3, so that would not be an irrational number. The two that I always remember are square root of 2 and pi. Pi is an irrational number. It's got an infinite number of decimal places. So there are others in the book, but these are the two lovely examples of irrational numbers. This whole box, this whole concept of all these sets of ideas are all considered real numbers, and that's why we put this kind of overall title on the diagram that we've drawn here. Now keep in mind that there are such things as imaginary numbers. The Algebra 2 girls have just started playing with those, and we'll talk about them when you get to Algebra 2. But for now, we're not dealing with them. We're just looking at this whole set, multiple sets of numbers that are considered the real numbers. So the homework for this problem set, this lesson, are simple things like this. 1/2 is an element of what sets of real numbers? So in other words, they're saying, where does 1/2 fit into this whole big crazy diagram? And as you can see, that it's not 1/2 is not a natural or counting number. It's not a whole number, and it's not an integer. So we can say that 1/2 is an element of the rationals, because it can be expressed as a fraction, so it fits this category. And since this one is a subset of this one, we can also say that it's a subset of the reals. Make sense? 61. So this is example 61.2. 61.3 asks about 5. 5 is an element of, let's see, which ones would you say? 5 goes all the way here to, it's a natural, whoops, turn my page, sorry. 5 is a natural, and it's a whole, and it's an integer, and it's a rational, and it's a real. And obviously, as I'm sure you guys have figured out, if you're in any box that you're inside of, you're inside of all the other ones too, right? So if you're a natural number, then you're all of those things. If you're a rational number, you're not one of those. So the boxes kind of work like a sorting mechanism to help you see which sets fit into the others. And then the last, well, let's see, 61.4 asks about 3 square root of 2. Which one is he an element of? Oh, square root of 2, dude, that puts us over here in crazy land. So he is an element only of the irrationals. Okay, and then there are some true and false questions that you can see on the bottom of my page 250 that asks about whether the categories fit into each other. And again, you can just look at the chart, and I think that the book does a good job of laying those out, so I won't go over those. But yeah, that is lesson 61. So look over together example 61.5, and you will be all set for the practice. Good luck with that.